Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 7, replacing letters with numbers. Classwork example 1, here is a grid. It's 3 wide, 3 tall, 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. And we're going to answer questions about this diagram. It says, what is the length of one side of this square? So if I look at this, this is one square, or one unit, this is one, and that is one. So the length of one side of the square is 3 units. It didn't say inches, it doesn't say feet, meters, centimeters, none of that. Whenever we don't have a unit of measurement, we simply say units. The next question says, what is the formula for the area of a square? Well, area of a square or rectangle is length times width. But in a square, the sides are equal. So let me get rid of these ones here. So if I call this S and I call this S, this is length, this is width. So we're used to seeing area equals length times width. But in this case, I can substitute, say it's side times side. But when I have two sides that are the same, then I can simply say area equals side squared. So A equals S squared. Then it says, what is the square area? What is the square's area as a multiplication expression? As a multiplication expression, it'd be 3 units by 3 units, or times 3 units, and that's what the word by means. 3 by 3. 3 by 3. 3 units by 3 units. Next question says, what is the square's area? So, if I use the formula like I did up here, I'm a big proponent for writing a formula, substituting in our given, our known side, and then simplifying that, coming up with a solution. So write the formula, substitute, solve. Don't forget to say units, and now that it's area, it's units squared. We can count the units. However, look at this other square. Its side length is 23 centimeters. So what they're saying here is, I could have simply said 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, this has 9 squares, so it's 9 square units. Okay? It's true. But if they give us a diagram and we know that one side's 23, but we don't have all the lines showing all the grid, then there's no way of just sitting there and counting. If I count, then I'm going to say, well, it's only, sorry about that. I'm going to say it's only 1 square unit, because it's a solid figure. Okay? So what we really need to do is, we need to use an expression to find the square's area. So what is the area of the square? Use a calculator if you need to. So I'm going to be writing this formula again. Area equals side squared. Since it's a square, and we're told it's a square, then I know that this is also 23 centimeters. The area of a square is side squared, so A equals 23 times 23, or the area equals 23 to the second power, or squared. So A equals, okay, I brought in my calculator, so I can either do 23 times 23 to get 529, or I could have just simply done 23 quantity squared, and that equals 529. So my answer is going to be 529 centimeters squared. Exercise 1. Now it's your turn. Complete the table below for both squares. Note, these drawings are not to scale. Okay, see if you can do this on your own. Answer the question, fill in the table, and pause the video, and then come back and check. Okay, hopefully you've done this. Let's check, see if you did it correctly. the length of one side of the square. So let's start with this square here. The length of one side is this side here, and that's 4 units. I do not know a measurement. It does not say, so I'm going to call it 4 units. And the square's area written as an expression, well, if that's 4, this is also 4. So I'd say 4 units times 4 units. Okay? The square's area written as a number, well, I'm just going to show my word. Area equals 4 squared, which equals 16 squared. Okay? So now I'm going to do this one here. Well, this side's 25 inches, so if that's 25 and this is 25 as well, they're equal. It's a square. So the length of one side of the square is 25 inches. We now know that it's inches because it tells us that right here. Okay. The square's area written as an expression, let's say 25 inches times 25 inches. And when I do that, I get 625 inches squared. And that's where the inches squared comes in, by the way. If you write it this way, inch times inch equals inch squared, unit times unit equals square unit. Okay, it's the whole thing. And that's where that comes in. Okay, example 2. What does the letter B represent in this blue rectangle? B represents a length of 8 centimeters, but it says B centimeters, so B is simply 8. We wouldn't say B equals 8 centimeters, so it's 8 centimeters, that'd be centimeters squared. So we just say B equals 8. Now it says, with a partner, answer the following question. Given that the second rectangle is divided into 4 equal parts, what number does the x represent? Okay, so I'm going to pause this, see if you can come up with this on your own, and then go back and check. Okay, so what you should have seen is if each of one of these are equal, so this is 4 centimeters, this is 4 centimeters, this is 4 centimeters, and this is 4 centimeters. Right? Well, if this is 4 centimeters, then I can move these all up here, and they're equal because they're opposite each other. It's a rectangle, so if these are all 4 centimeters each, x is representing 2 of them, then x represents 8 as well. Okay? Okay, unfortunately, they do this a lot in this format. You switch pages, and the question continues. You have to keep going back and forth, back and forth. But anyhow, let's deal with it. How did you arrive at this answer? Okay, well, I kind of just explained that. I'm not going to write that in here. We're just going to say, since one length from here to here is 4, and this is 4, and this is 4, and this is 4, so I have 2 lengths 4. 4 times 2 is 8. What is the total length of the second rectangle? Okay, so now I'm going back. This is the second rectangle. They want to know what the total length is here. One is 4 centimeters. I have 4 of them. So I would say the total length of the second rectangle is 4 times 4, which equals 16. And make sure I get my unit of measurement here. See what I mean by going back and forth, scrolling. Okay. Centimeters. So 16 centimeters is the length of the bottom. Now it says if 2 large rectangles have equal lengths and widths, find the area of each rectangle. So now it's saying if the 2 large rectangles have equal lengths and equal widths, find the areas. So they're saying that this has to be 8 here, and this was 4 times 4, which is 16, so I can put 16 here, 16 here, 8 centimeters here, and I suppose I should have centimeters here as well. and we knew that B was 8. So these are equal rectangles, so I took this side, the height from this one, and applied it to this because they're equal. I took this length from this one and applied it to this because they're equal. So now we have a 16 by 8 rectangle, and the area of a rectangle is length times width, so the area equals 16 times 8, and therefore the area is 6 times 8 is 48, carry the 4, 8 and 4 is 12, it's 128 centimeters squared. They are both 128 centimeters. Okay, now it says discuss with your partner how the formulas for the areas of the squares and rectangles can be used to evaluate area for a particular figure. Okay, I'll leave that up to you, and I'm going to move on. Exercise 2. Complete the table below for both rectangles. Note these drawings are not to scale. Using a calculator is appropriate. Okay, some fairly large numbers here. Alright, so try this, pause the video, come back, see how you do. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7. Length of the rectangle, 7 units. 1, 2, 3, 4 high. Width, 4 units. Rectangle area, 7 units. Times 4 units. And that is 28 units squared. This one, the length is 46 meters. This is length. This is width, 32 meters. So 46 meters times 32 meters is the area written as an expression. 46 times 32 is 1,472 meters squared. Example 3. These are three-dimensional figures. They're rectangular prisms. This is what they're actually called. This is length, this is width, and now we have a height. Length, width, height. What does L represent in the first diagram? It represents length. What does the W represent in the first diagram? Width. What does the H represent in the first diagram? Height. Okay? And let's just say the length of the rectangular prism. The width of the rectangular prism, the height of the rectangular prism. Since we know the formula to find the volume is volume equals length times width times height, what number can we substitute for the L in the formula and why? So if I come up here, here's my L, it's in the same location as this, so we can substitute 6m, so L equals 6 centimeters, because they are corresponding sides, because the length of the second prism is 6 centimeters. What other number can we substitute for L? If I go back up here, what other number can we substitute for L? None. What number can we substitute for the W in the formula and why? So if I come up here, here is W, and this corresponds to W, so W equals 2cm. The reason is because the width of the second prism is 2 centimeters. I'm not going to write that, but that's what we'd say. Because the length of the second prism is 2 centimeters. The width of the second prism is 2. What number can we substitute for the H formula? So here we go. Back and forth again. H is here. H is here. H is 8 centimeters. So I'd say H equals 8 centimeters. Determine the volume of the second right rectangular prism by replacing letters in the formula where their appropriate numbers, with their appropriate numbers. So I'm very picky when it comes to this. Write the formula. Volume equals length times width times height. Substitute givens. Height is right here. I'll put that in first. The width, I believe, was 2, and the length was 6, but I can go back and verify. 6, 2, and 8. That is correct. 6, 2, 8. Okay? So write the formula, substitute the givens, and simplify and solve. PEMDAS says to multiply left to right if that's all you have. So that'd be 12 times 8. So therefore the volume is 96 centimeters. Now this is volume, so it's cubic centimeters. Okay, exercise 3. Complete the table for both figures using a calculator is appropriate. Try doing this on your own. Come back and check your answers after. Okay, length of this rectangular prism. Length, 12 units. Width, 5 units. Height, 15 units. Rectangular prism's volume written as an expression, 12 units times 5 units times 15 units. Rectangular prism's volume written as a number, 12 times 5 is 60. 60 times 15 is 900 units cubed. Now I wrote it this way, 12 units times 5 units times 15 units for a reason. I multiplied the 12 times the 5 times the 15 to get the 900 units. And then I wrote units to the third power because it's units times units times units, which is how we write cubic units. Okay, so we multiply the unit measurement as well. And then we go on to the next one. Length is down here. This is my length, so that's 23 centimeters. The width is 4 centimeters, and the height, it is 7 centimeters. So I'm going to write 23 centimeters times 4 centimeters times 7 centimeters. 23 times 4 times 7, 644 centimeters cubed, or cubic centimeters. Okay. Here's the lesson summary. 2 definitions, variables, and expression. So please read this on your own and go do your problem set.